Video lesson 9.5, using logs. So we're going to deal with compound and continuous interest for this video. So again, this is something that you may have seen before, but I just kind of want to reiterate and just make sure we're all on the same page with it. But so here we're dealing with, this is our, compounded interest formula, right? A is going to be the, your total amount, right? That's what's going to result in the, this process. P is the initial amount. R is your rate. N is what is compounded. And T is your time. Okay, so just let's look at this first example. This has got a lot of different versions of what we have here. We'll write out the formula and kind of represent each of these. So just compounded annually here. We're going to have here A is going to equal 1,000. We've also got here the 1 plus R in this case is 1.0. Again, we gotta make that a decimal. We're compounding in this case annually, so it's just 1. And it's going to be 0.10 times 1 is an exponent. All right, so once I have this, again, simplify this. I would personally simplify this and then plug it in the calculator, but let's take the opportunity to do that now. It's going to give us, I'm getting 11,000. For that. Semi-annually, right? Same scenario, but now we're going to have 1,000 times 1 plus 0.10 over 2 raised to the 0.10 times 2. All right. Again, I would personally simplify this, process so I don't have to plug all of this in, right? But if I plug this into, once we plug this into the calculator, I'm getting 1,102.50 cents. So not a dramatic change, but as you can see, it does increase. Quarterly, that's going to be 4 times, in this case, a year. So that's 1,000 times 1 plus 0.10 over 4 times 0.10 times 4. This is going to give us 11.03 and 81 cents. Monthly, 1 plus 0.10 over 12. This is coming out to be 1,104.71 cents. All right, so we're growing here, but obviously it's not a dramatic change for each of them. But that is because we are only getting this, even though the how the rates being compounded is changing, it is all just with respect to 1 year. So obviously the more years you go, the more dramatic the difference is going to become between them. So A is equal to 1 plus 0.10 over 365. And that's 0.1 times 365 is the exponent. And I'm getting, plug that in. We've got 11.05 and 16 cents for that one. So you can see there's a change. Obviously, the more you do this, the more it gets compounded, the more it increases. And like I said, for the more time that it occurs, that change is going to grow more quickly. So, if you did this, instead of doing it for 1 year, if I did it for 10 years, you would see the growth change respectfully, but there would be a bigger gap between each of them because it's growing and it's growing more and for a longer period of time. The other one is the compounded continuously. We can utilize this formula here. A is equal to P E raised to the RT. Also, a lot of times people refer to it as PERT. From here, so the information is the same here. A is your total amount that you're going to make here. Again, that's again, total amount is again your interest plus the principal that you put in there. We had initial amount. R was our rate. I think I did that in green. And time. Nope. We've got time for T. All right. So yeah. So just again, we're plugging this in. Obviously, we just got to use. Make sure we be careful here, since in this case we have E. E is our constant. All right. It's a mathematical constant. We got to utilize that, and then we can plug this in. So we've got here amount revert and the continuously compounded. So we're going to do that same $1,000, right? As my initial. So A is going to equal 1,000 E to the 0.10, and we're just going to do 1 year. All right, so if I take this and plug this in, this one I'll show just because of the E. Again, you know, you can plug the whole thing in. I'm not a big fan of that. I'd actually, when I type it in, I actually do it in parts. So I do like the exponent portion, which in this case just times 1, right? But I'd hit enter, then I take the E, which is second divide sign. I raise it to the answer that I just took, right? And then I multiply that by the principal, which in this case is 1,000, and then I have my answer. As you can see, is 1105 and 17 cents. All right. So, yeah. So here. So again, continuously, meaning is happening over and over and over and over and over again. You know, and this, basically, essentially, it's like daily. It's happening. You know, continuously throughout that entire process. Again, this is one that's a lot more relevant, especially when you get to calculus. You know, becomes a little bit more relevant because it allows us to kind of take the situation at hand as it goes, utilizing that continuous rate. How can we use logs for here? So the big thing is if I'm asked to find something that's an exponent, any of the exponent parts, then I need to use the log form to do that. Most typically, it is finding the time. We can work backwards to kind of figure out what that time is going to be for something to happen. So here, how long will it take for $5,000 to double at a rate of 7%? So if we do this monthly, so again, we've got A is equal to P times 1 plus R over N to the NT. So we've got, in this case, we've got an investment of 5,000. We want it to double, so that makes it 10,000. So A is 10,000, P is 5,000, 1 plus our rate is 0.07. We're compounding monthly, that's 12. So that's 12, and then T is what we're looking for. So the thing is, honestly, if I know that it's doubled, I don't even have to do all this, because look what's going to happen when you do this, right? This is all multiplication right here. So if I divide out the 5,000, right, I'm going to get 2 over here, right? And that should be because it's doubled. So no matter what, the second I know that it's doubled, you can actually shortcut this and just simply say 2 equals and eliminate the P and just have everything else. But again, you know, it's not the end of the world if you don't, but it is something that you can do to make your life a little bit easier when dealing with this, and then you don't have to worry about it. So, all right. So this part here, I'm going to just plug this in the calculator real quick and simplify that. I got this fraction, right? Just so that I don't have to keep writing that craziness, right, to the T. All right. So at this point here, now here's where I'm going to use logs. So if I take the log of both sides here, that allows me to power down the exponent. So again, I can take the log of both sides, right? That's going to take this and it's going to put it in the front. So now I'm going to have log 2 is equal to 12t times the log of all of this giant fraction, right? Like so. All right, and now I can solve for t, because now it's all just multiplication. So now I can go back and just divide each side by these two parts, 12 and the log. So 12 and this log, and I'm going to do 12 and this log. That'll eliminate all of this. And now I'm going to have t is equal to the log of 2 divided by 12 log of 12/7 over 1200. And if I plug that into the calculator, let's take a moment here. So I've got, I'm going to do it as a fraction bar, probably make it a little easier. Here we've got log of 2 over 12 log of, another fraction bar, 1207 over 1200, like so. Hit enter. I've got a 9.93 years. All right, so let's see what happens if we do that continuously. So now we're using A is equal to PERT, PERT. This is, again, the double portion. So I could put 10,000 for here and 5,000 for here, but then I'm just going to divide it out. So this is just going to end up being 2 equals e to the RT. So now I can plug in the R. So 2 is equal to e 0.07t. And if I take the log of both sides, I can power this down. But now I can't just take regular log. I gotta take the natural log because I'm dealing with e. So now I take the natural log of both sides. And that allows me to power this down. So I'm gonna have natural log of 2 is equal to 0.07t natural log of e. This is one of our little rules. The natural log of e is just 1, so that kind of drops out or goes away. And now I can divide both sides by 0.07. And I'm going to get t is equal to the natural log of 2 divided by 0.07. So now if I plug that in, again, natural log is over here. So natural log of 2, right, divided by 0.07. I get 9.90. So actually very close to being the same. So we got this is approximately 9.90 years for this one. So obviously these answers were very close to each other, but again, there is a difference. And you can see that this process definitely was a little bit nicer overall, because being able to solve or work out the log portion is simpler. The expression is less complicated. But again, the key to this one is remembering that you have to use natural log. All right, take one more example here. So we've got Angela has $100 to invest at 10%, compounded monthly. How long will it take to make $175? So let's see about that one. So for compounded monthly, so we're going to have A is equal to P times 1 plus R over N to the NT. So I want 175 to equal 100 times 1 plus 0.10 over 12 raised to the 12t. All right, so now again, we're going to try and simplify this as much as possible. I'm going to get rid of the p part and get rid of the principal by dividing that out. So when I divide that part, what's that give me? That's just 1.75. This here is going to simplify down to was this 121 over 120 to the 12t. I'm now going to take the log of both sides. Right, that allows me to power down the exponent. So log 1.75 is equal to 12t log of 121 over 120. And again, I can now divide out the 12 and the log. Divide by 12 and the log. So I get t is equal to the log of 1.75 divided by 12 log of 121 over 120. And for this case, let's plug this in. For here, we've got, oh, actually I already have it written down here, so whoops. So I have that as 5.61 years. For that one. It says, another one says, can we compound it continuously? So let's see. I would expect this to be somewhat close to this here, but let's see. A is equal to P raised to the RT. So that's going to be 175 is equal to 100 E raised to the 0.10 T. So again, divide out that 100. So I get that 1.75 is equal to E to the 0.10 T. Again, now I take the natural log of both sides, since I have to deal with E. So natural log of 1.75 is equal to 0.10 T times the natural log of E, which just cancels out to be just 1. So I can now divide by 0.10. A much nicer equation here. Oh, that's a 1. All right, solving process, I mean. So T is equal to the natural log of 1.75 divided by 0.10. And that's going to be approximately, here, I get 5.59 years. So not a dramatic change, difference, but as you can see, there is still a little bit of a difference for that one. So in this case, for her to increase that $100 to by $75, either version of this at this specific rate, grows kind of slowly here, but it would take over 5 years to accomplish that task. So, but that's the process. So being able to solve them using logs, very helpful, and we'll utilize this a little bit more. So take opportunity to review any of these questions that you may have, rewatch any portion of the video to help, and don't forget to use the practice problems for more understanding.